Every model has knobs you can turn, but they come in two very different kinds, and mixing them up is a classic source of confusion. Let's separate them clearly: the parameters the model learns, and the hyperparameters you set. First, the learned parameters. These are the numbers the model figures out for itself, from the data, during training. For a straight line model, that's the slope and the intercept. Training nudges them, step by step, until the line fits. You never set these by hand. They are the output of training. Then there are the hyperparameters. You choose these before training even begins. They don't describe the answer. They configure how the model learns, how deep a decision tree can grow, how many neighbors to look at, the learning rate, the strength of regularization. The model can't discover these on its own. That's your job. Think of baking. You set the oven temperature and the timer before you start. Those are the hyperparameters. The cake that comes out is the result. That's the learned model. You'd never try to read the perfect temperature off the finished cake. You set it up front, then judge the cake afterwards. So how do we choose good hyperparameters? A tempting idea: just pick whatever makes the training error smallest. But that's a trap. The lowest training error always comes from the most complex model, the deepest tree, the weakest regularization. That's overfitting. Straight back to lesson 1. Instead, we judge hyperparameters by the cross-validation score. That rewards models that generalize, not models that memorize. Here's the whole loop. Choose a set of hyperparameters. Train the model. It learns its parameters. Score it with cross-validation. Then adjust the hyperparameters and go around again, keeping whichever setting scored best. And notice, once more, this entire loop runs on training and validation data. The test set stays sealed. So, parameters are learned from data. Hyperparameters are set by you and judged by cross-validation. But trying settings one at a time by hand is slow and haphazard. There's a systematic way to search through many combinations at once: grid search and randomized search. That's next.